Hello everyone, welcome to another day of daily LeetCode live streams where we do LeetCode problems, try to do as many as we can, learn some new things along the way, and just have an overall good time. So today we're going to be doing some easy questions. Yesterday, if you tuned into my stream, you know that I started doing something new where I actually do medium questions, and what I'm thinking about doing moving forward is I'll have medium questions on Tuesdays and Thursdays, and then easy questions on Monday, Wednesday, and Friday. I realize that there are people that do want to see that medium content, and it's also fun for me to sort of break things up a little bit. So that's been very rewarding, and of course I'm looking forward to continue down that path. Also, I should note that on my website, rafaelslist.com, I've gone ahead and made some updates to it. So I just want to talk about those now real quick. So one of the first things I did was now on top of here, I now have an icon that shows the Spotify icon. So you can go ahead and watch the podcast. I have the next episode tentatively scheduled for September 30th. So very much looking forward to that next one. Go ahead and follow that if you're into that. I also put a link to the next playlist I started for the next Explore card that we'll be visiting through LeetCode called Arrays 101. So if you want to look at that content, you can just click on here. It'll take you to that YouTube playlist right here. And then finally, you'll notice there's also a new medium section here that I'll be starting to add my own top quality medium questions that we come across. So with all that being said, I think this is, this website, it's been evolving ever since the first day. I'm glad with where it's gone now. If this is something you like, if you like LeetCode, if you enjoy problem solving, then make sure to subscribe to the channel, follow me on Twitch. If you are on Twitch, I recommend that you also check me out on YouTube because I'll put a lot more content there. The only thing that Twitch people get are the live streams, but I also do other things on YouTube. All right, so with that being said, let's just go ahead and continue from where we left off last time. I don't remember having seen max consecutive ones before, so let's just go ahead and solve this. I will say that I recently solved this. Actually, if you look at this playlist, like max consecutive ones was right here. I have already solved this, and really we can just sort of breeze through this one. We'll consider it like a freebie. So although I see that like the likes and dislikes, I mean, it's good. Like a lot of people love this question. So maybe there's an easier way of doing this that I'm not even aware of. But what I'm going to do is say one's count is equal to 0 and one's max is equal to 0. Say for const n of nums. All right, so if n is equal to 0, then what we're going to do is one's max equals math.max of one's max or one's count. And we'll say one's count equals 0, else one's count plus or equals 1. And then at the end, we'll just go ahead and return the math.max of one's max or one's count. So we just go ahead and run this. We get 3 and 3 for that first test case. Went too fast. Let's go ahead and see our second one here. Second run. 3 and 2, 3 and 2. Let's submit this. Yeah, so like I said, had already gone through this. I consider this sort of a freebie. But now I'm curious, like, is there a better way of doing this? Because this is linear time and constant space. And maybe there is, because when I see something so good like this, like the like to dislike ratio, there must mean maybe we're missing out on something here. 4 lines, concise solution with explanation. The idea is to reset max here to 0 if we see a 0, otherwise increase max here by 1. Okay, yeah, that's cool. That's pretty much exactly what we did. So if anything, I'm just going to blame it on JavaScript. All right, let's go ahead and get to our next one here. So path crossing. It's like Animal Crossing. Okay, given a string path where path of I is equal to north, south, east, or west, each representing moving 1 unit north, south, east, or west, respectively, you start at the origin 0, 0 on a 2D plane and walk on the path specified by path. Return true if the path crosses itself at any point. That is, if any of the time you're on a location you have previously visited, return false. Otherwise, okay. So if we're at, NES, Nintendo Entertainment System. That's awesome. So we go to north, east, south. Okay, that's not good. But here we go like 0, 0. And let's write out all the different coordinates here, right? We go 0, 0. Then we go 0, 1. Then we go 1, 1. And then we go, let's see, 1, 0. So we don't ever come across another coordinate that we've already seen. But if we do like 0, 0, here we'll go 0, 0, 0, 1, 1, 1, 1, 0, and then back to 0, 0. So we can just immediately return true as soon as we find a coordinate that we've been to previously. I think what I would like to do for this is if I try setting, oh, I definitely didn't want to do that. I can try, I mean, I think using a set would be nice, but I also don't know. Let me see. I wonder if it's possible to use like a bit mask. Maybe not. That might be making it like much harder than it needs to be. I think I can just store these in like a dictionary because I can't, I mean, maybe I can make this a key somehow. Maybe I guess I can stringify this and put that inside of a set, but I'd rather just maybe make it a key and do it that way. So we can have crossed paths equals a new set, or rather we'll just set this equal to an object literal. I can say for const path of paths if crossed paths, and let me see something. We start at 0, 0, but even inside of here, if I try to do, because keys are generally strings, right? At least that's typically represented that way. So if I try to do like let obj equals this, and I say obj, if I do 0, 0 equals 5, how does that actually, oh, okay, so that's not actually being, doesn't actually come out that way. So I think at the end of the day, I'll still have to make a key. We have cross paths, and then we'll have let origin. Or we can just have let x equals 0, let y equals 0. This reminds me a lot of like this robot return to origin question that I think we've done before. So we first need to like know where we currently are. Like we're gonna start at 0, 0. So if cross paths and then dot has, so let me think of like coming up with an origin key, something like const origin key or coordinate key. Coordinate key equals, we'll set this equal to a template literal. Here I'll do x and I'll do y. We can do something like this. And I can say if cross paths of coordinate key is not equal to undefined, then we can return true. Else here, what is it that we want to do? We want to actually now set cross paths of coordinate key equals to true. That's like one thing we can do. So now we've already been to 0, 0. We'll set that equal to true, and that's fine. Now the next time we come, like if it's north, and then I actually want to move to the next place now, right? So this I feel is where I can make my next decision. So for const path of paths, here maybe we can do something like switch path. We can have a case for each one, like if case is equal to north, and I'm just going to copy this 4 times. I have north, east, south, west. Here we'll just do, if it's north, we'll do x or y plus or equals 1, and we'll break. If it's east, we'll do x plus or equals 1, and we'll break. Oh, if it's south, we'll do y minus equals 1, and we'll break. And if it's west, we'll do x minus equals 1, and then we'll break. So let's think about how this is going to work. So we start at x equals 0, and our path is NES, Nintendo Entertainment System. We're going to create our first coordinate key. It's going to be 0, 0. Inside of our object literal, we're going to check to see if cross paths of coordinate 0, 0, coordinate key 0, 0 is not equal to undefined. If it's not equal to undefined, that means we've actually been there before, so we can return true. Else, at that key, so here you can imagine we have a key that looks like 0, 0, 0. We'll set this equal to true. Actually, we'll do this. 0, 0 equals true. And then we do a switch on the path. So now we're going north, which means we're going to increase y plus 1. So now we have 0, 1. Right, so 0, 1 is not in there. So we'll go ahead and create our key. 0, 1. Right, and we'll set this equal to true. Then we get to the next one. We're going east. So since we're going east, we'll add 1, 1. We're going to check to see if 1, 1 is not equal to undefined, which it is equal to undefined. So we'll set this equal to true. And then finally, we'll just go down 1 south, which means that we'll do y minus equals 1. So we'll just go back down to 1, 0. So none of the keys are found. Now in this case, as we're building this up, let's see, I already see sort of an issue here because, well, actually no, because I do consider my first one here. So I am starting with 0, 0. We'll come back at some point and see 0, 0 again, and then we'll return true. At the end here, we can just return false. So let me remove all this stuff. Say x, y, 0, 0, and const cross paths. And let's go ahead and run this and see what we get. Oh, I see, for const path of paths. I guess here I can get direction for const direction of path. And then anywhere that there's path, I'll do direction. And that should be good there. So let's run this again. So we have false, false. Okay, let's run it for the next one. Too fast. False, true, false, true. Let me submit this. South and north, output false, expected true. Now we start at 0, 0. We start at 0, 0, and then we go down to 0, negative 1, and then we go back up to north. Okay, so why wouldn't that one work? Let's see. So 0, 0, const coordinate key is 0, 0. We put something at 0, 0, and then we're going south, which means we do y minus equal 1. Okay, so now we should end up with x negative, or yeah, 0, negative 1. Coordinate key is 0, negative 1. Okay, so we set return true, and then we go north, y plus or equals 1. Coordinate key is 0, 0. If cross paths of coordinate key not equal to undefined, return true. So maybe this should be, wait a second, if it's not equal to undefined, yeah, wait, I think I did this the other way. This should be if it's equal to true, right? If cross path of coordinate key is equal to true, then we return true, because that means we cross the path. So let's go ahead and let's open up our test cases again and add this one, just so we can account for all three. Else we return false at the end. So false, true, false. Still getting a false for the last one. Let's print out our coordinate key here. Console.log coordinate key. Something weird that's happening here. Oh wait, but I only want to see, okay, 0, negative 1. Oh wait, I see. I'm only putting, yeah, I'm not actually, I need to put 0, 0 in there first. Probably what I should do is do 0, 0. I'll set that equal to true. I'll create the coordinate key. Yeah, I think first what I need to do, if I start at 0, 0, then I should do this first, right? I think it was an ordering issue. I should get my direction first. So I'll get my direction first, then I'll create my coordinate key. If that's equal to true, that's fine. Else we just set it to true and go to the next one. So we're at 0, 0, we go south. If it's true, which is not, return true, but then we set it to true, and then we go back north. Now both of them are 0, 0, and we should get the right answer there. So let's again add that. Let's do s of n. This is why it's very important to like debug yourself like this. So false, true, true, false, true, true. All right, that's looking better. So let's go ahead and submit this now. Okay. ENNNEEESSS. Okay, so that acceptance rate's going down today, boys, or boys and girls. But my YouTube analytics show that actually I think 100% of my audience is male. So what can be the case here? I guess we're just gonna have to draw it out, because I'm starting at 0, 0, which means that I've already been there just by virtue of that's where I start. And then as I go along here, we go east. And let me just make sure I actually did this correctly. So y plus or equals 1, x plus or equals 1. right? Because that's east, south is -1, and west is less than or equal to 1. Break, break, break. We got the const coordinate key. Return true, else return false. So east, north, 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 north. So when, well, I guess let me actually see this. So cross path is already that. Coordinate key, yeah, let's log the coordinate key again. And this time I just want to do it for this input. So at some point there's going to be, okay, 1 0 1 1 1 2, okay, 1 8 1 9, and then there's 1 10. Oh no, that should be fine though. 1 1 0 1 1 1 2 1 1 3 1 4 1. Okay, that's all fine. 1 0 1 1 1 1 9 1 1 8. All right, 1 1 1 1 1 2 1 1 3 1 1 1, and then we get to 1 1 1 here. So is it because, how is it interpreting this key? Like 1 1 1 1 means that we got to, yeah, unless I need to like come up with a better way of representing my coordinate. Maybe I can do something like, because north, 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 this would be 0. We start at 0 0, and we go east, so we go 1 0. Then we start going 1 1, yeah, right? 1 0, which is east, and then we go 1 1 1 2 1 3. We're just moving north, and then we're getting to 1 1 0. But I guess 1 1 0 can also be interpreted for, like, it could be that we're on like x1 y10 or x11 y0. So maybe what I can do is give each one of these, like, let me think about this. What would be a nice way? Can we do that with a set that I like look for? No, because that's all references, right? But now if I do it with an object, I guess what I can do is I can do crossed paths, and I can have something like anytime x is 1, maybe I create a separate, no, maybe that, I don't know if that would work too well. I essentially just want a way to store all my coordinates and then quickly find if I've already visited a coordinate in the past. So what's the best way for me to store these? I do feel like an object literal is the best way to do it. I'm just thinking about the representation of that object literal. I can have x's and y's. I don't think I need a key. I think, like, what if I also create something that looks like x and then y? But would that help? Have I been to one where y is 11 and x is 1? But those are not like paired. So I almost need to have like pairs of these where x is something and y is something. But this wouldn't allow for me to like index these very quickly. Also, what I could do though is maybe, okay, I think I know what I can do. What if I instead gave the key more information? I did something like x, y. That way it's very clear that like this one's the x and this one's the y. Can try this out. So let's look at that 1 1 1 again. I think that's where we got like mixed up. So like x1 y11, and here we have x11 y1, right? False, false. So here it's just a matter of like I created a better key, and here I should also do x0, y0 to keep it all consistent. So now let's again copy this input here. Let's run all our test cases. Let's not forget the one that we failed on before. Let's also use our new one, and now let's go through all this. So false, true, true, false, false, true, true, false. Let's submit. Third time's a charm. Third time's a charm, baby. All right, nice. Yeah, 28.44. Let me think about if there's a better way of doing this, because this will be linear in terms of having to go through each direction, right? And anytime we're just creating a new string here and using that to index the coordinate key, that's constant. As far as space complexity goes, it's going to be every unique coordinate in our path, which is not necessarily, I guess that would be, in the worst case, if we never cross paths, it will be n. It will be the size of path. So is there a way that we can do better here? Maybe instead of having a cross path, we can create a set and have the set contain each one of these individual keys. So if I do, because is that really going to be better? Well, let's try it out. Hash set visited. Yeah, that's like what I'm thinking about doing here. We can do something like const visited equals new set. Let me set this equal to here. I just want to set initially with this string. I'm pretty sure we can just initialize a set with a value like that. Const s equals new set. Oh, is it gonna? No, I need for that to be. How do we make it just a single? Can I not have? Oh no, because that's gonna be an array. I can't have a set of strings. No, it can't be. Interesting. So when we add it like this. So if I do s.add x1, y2. Oh, but now it takes it as an array. x1, y2. I see. So when we initialize it, we pass it in as an array, but then we can just say, okay, so here we have const coordinate key if visited dot has coordinate key, then we return true, else visited dot add coordinate key. And let's remove const cross paths here. See what we get. Oh, one extra parentheses. Classic problem. False, true, true, false. False, true, true, false. All right. 59.63. So that seems like a significant improvement right there. $84.40. Yeah, that's nice. So I feel good about this question. Yeah, I guess using the set here helped us out a lot. And it's a very nice way, because this pattern of keeping track of previously visited nodes is almost sort of like it's like a graph. Actually, that's exactly what it is. It's just a graph. These are like different nodes here. So it's just a nice pattern that we'll definitely use a lot as we get into more harder easies and also mediums when we get there. Cool. So let's get to the next one. Nim Game. You are playing the following Nim game with your friend. Initially, there's a heap of stones on the table. You and your friend will alternate taking turns, and you go first. On each turn, the person whose turn it is will remove 1 to 3 stones from the heap. The one who removes the last stone is the winner. Given n, the number of stones in the heap, return true if you can win the game, assuming both you and your friend play optimally. Otherwise, return false. Yeah, I think this one, if I remember correctly, it was a super cheesed answer, which is why the like to dislike is so bad. I think it's just like return n modulo 4 is equal to 0. Okay, maybe it's not that. Or is it 1? Maybe. Because that's no, because then that wouldn't work. True and true. It was something like this. I don't know if it was like, yeah, the answer was like whack though, but we'll figure it out. We'll figure it out. Readability too. Oh, for sure with the set, right? All right, so you remove 1 stone, your friend removes 3 stones, including the last stone, your friend wins. You remove 2 stones, your friend removes 2 stones, your friend wins. You remove 3 stones, your friend removes the last stone, your friend wins. In all outcome, your friend wins. Oh, I think it's you can win it if the number is not divisible by 4. Yeah. False, true, true. False, true, true. Nice, 90.17. Yeah, this one was like, I mean, I hope that I sort of explained a little bit, because as I'm reading the description, it kind of makes sense. Like, you can only ever win, or you can win as long as the number is not divisible by 4. That sort of made sense to me. Give me 1 second. I need to put the AC on in my home. If anyone lives in Florida, you know how it is. I live in South Florida, so it's pretty hot. All right. Let's keep it going. I'll consider this one a freebie. Constant space and constant time. Beautiful. 1, 1. O of 1, O of 1. Largest odd number in a string. Although, well, maybe... Is this... I know it might sound like a dumb question, but is this actually constant time? I'm not sure. Largest odd number in a string. You're given a string num representing a large integer. Return the largest valued odd integer as a string. The only non-empty substrings are 5, 2, and 5, 2. 5 is the only odd number. There are no odd numbers in 4206. Substring is a contiguous sequence of characters within a string. Okay, so 5, 2, but 2 is not. So I almost feel like we want to keep, like I sort of get what it's doing. Sort of understand here, because we have like a 3, 5, 4, 2, 7. Like, even though here it's even, we keep going right and we still end up with an odd. So we need to figure out, let me see, largest odd number in a string. How can I figure out here? If I have 3, 5, 4, 2, 7. I'm at the 3, okay, that's odd. Then I get to the 5 and I say, okay, that's odd. Now, if the next one is not, if the next one's even, it doesn't mean that the rest of it can't also be odd. But you know what? I guess as long as the last one's odd, that's like the most important thing. Because if 7 is odd, like 2 is even, so we just go to the next one. These are all, as soon as this is, yeah, this is already an odd number. Not contain any, I'm going to try that. I feel like I want to start from the back. I want to start from the back, and I'll keep, because the largest number would be all the digits. If the last one's odd, then we just return that, no? Or would it be, yeah, I think that's a way to do it. We can figure that out. So I'm going to do for, let's see, for let I equals num.length minus 1, I greater than or equal to 0, I minus minus. So let's see, if And this is something I want to show you all because I actually learned this yesterday during a medium question that I was doing. So like here what I would do is something like if parse int of num at I modulo 2 is equal to 1, then I would just return num.slice from 0 up until I plus 1. That's what I would return. Else here we can just return an empty string. That's almost what I'm thinking. Like we'll just start parsing the digits. So let's think about 2 and 5. So if we're at 2, we're going to parse int 2. We're going to modulo that by 2 to see if we get 1. It's even, so we keep going. That's 5. Okay, so now we just return num.slice of 0 to I plus 1, which is 1. So 0 to 1, the last index is not included, so we just return 0. We just return the index at 0, which is 5. 4206, we go through this whole thing and we never enter this return, so then we just return an empty string. As soon as you get to 7, this one is even, or rather this one is odd, so we just return everything up until there, to I plus 1. So I think this could work, but this right here, so that's 5 and 5, 4206, let's see. 5 empty, 35427, okay. 41.22. Now, one thing I want to do though is like here, I was looking at like the time complexity yesterday of parsing an int, and it might not really make a difference, but it's like it's linear time depending on how many digits we're passing here. Now, this is only a single digit, and we know it's going to be that every single time. So I guess for all intents and purposes, this is probably constant. But something else that I saw yesterday was like we could do num of I dot, or let's do this. Let's do const digit equals num of I dot car code at 0 minus 48. So 48 represents the number 0 in ASCII. So if it's like 9 minus 48, we'll be left with the number 9. So this is an easy way to sort of like convert or parse single digits. And in this case, we're only ever dealing with a single digit. So here we can say if digit modulo 2 is equal to 1. We'll still do the same thing, but I'm wondering if that might work like faster. 5, empty string, cool. So, I mean, LeetCode times vary wildly, but we literally went to the 90s. I forget already, but I think before we were like, well, look, 122 milliseconds and now 77 milliseconds. It could be that we just got lucky. Let's try again and see. Okay, so right back to where we first started, but I like this trick a lot. It's something I learned while doing medium questions yesterday. It's just another way to parse single digits instead of using parse int. And 48 is sort of like using the number 97 when you're trying to map like a lowercase a to index 0, lowercase b to index 1, so on and so forth. When you're dealing with algorithms that just deal with lowercase strings, it's a very common trick you see. So that's pretty cool. I like that a lot. It's a pretty neat trick. So let's continue. We're doing like very good today. I think we've done 3 questions. I think that's pretty good for the amount of time. Oh, and 4 because we did max consecutive ones. So let's get to this one, degree of an array. Given a non-empty array of non-negative integers, nums, the degree of this array is defined as the maximum frequency of any one of its elements. Your task is to find the smallest possible length of a contiguous subarray of nums that has the same degree as nums. Okay, so the input array has a degree of 2 because both elements 1 and 2 appear twice. Of the subarrays that have the same degree, so 1, 2, 2, 3, 1. Okay, 1, 2, 2, 3, 2, 2, 3, 1, 1, 2, 2. The shortest length is 2, so return 2. The degree is 3 because the element 2 is repeated 3 times. And we need, let's see, which one? Okay, this is the degree because the 2, okay. This one's interesting. Let me think about how we can do this. The smallest possible length of a contiguous subarray of nums that has the same degree as nums. So it's like we just need to find, I think what we can do is this. Like first, we're gonna have to find the degree first. That's like one step, find a degree. But then let's say here, we know the degree is 2, so we'll need to find a spot where like here the degree is 1, here the degree is 1, here the degree here is 2, but then it's like, can we cut off 1 at the end to make it shorter? If we go here, the degree is still 2. I feel like this could be a sliding window. I'm not normally very good at these questions with sliding windows. They've been like historically tricky for me, because if I get to like, I guess as soon as we find, because what happens if like, well, I guess as soon as I find my degree, 1 2 2 3 1 1 2 2, would it always be that? Like, what if it was like this? Well, I guess I would get to the 1. Here it would only be 1 2 3 1 or 2 3 1 2. So it's almost like we can have a pointer that goes from left to right until we find our degree, and then we can just shorten it from the left as long as the degree is the same. That's what I'm going to try and do, and then we'll go from there. So the first thing again is find the smallest possible length. The degree of this array is defined as the maximum frequency of any one of its elements. So let's think about this, because to get the maximum, we could use a heap to keep track of the frequency of each one of these. Yeah, we could do that. Is there a better way of doing that? The one with the highest frequency? I wonder if I can do like a reverse math. Let me see. Nums.length. Okay, these are pretty large numbers. So, although this seems like a very specific number, but we'll leave that for the end. Or do we even need to keep track of the degree? Do we even need to keep track of... Oh, I guess the degree of this array is defined as the maximum frequency. Yeah, because if 2, 2, it could be that. Here it can be 3. How would we ever know? Yeah, we're going to need to figure out the degree first. I think that needs to be a step. Is a heap the best way to go? Yeah, perhaps. Not my favorite way of doing it, but yeah, I'm gonna need to look up like how to do LeetCode environment, because this right here tells me, links me to the library, and it's version 4.1. Okay, so let's go here. Give me a second to send a text real quick. Actually, give me like 30 seconds. I'll be right back, everyone. All right, we're back. Okay, so we need to go to version 4.1 of this so we can see how this is being used. So here, yeah, I think we can just do a max priority queue. On queue element and then priority. But do we also need to find, oh, that seems like crazy. Okay, so almost this might be like a 3-step process. I'm hoping, I feel like maybe this is over engineering it though, but let's go for it. So const frequency is our object literal. For const n of nums, we'll do frequency of n equals frequency of n plus 1 or 1. Now what we can do is we can do this here. Wow, a lot of things. Here we'll do const, say max frequency equals new priority queue. Okay, new max priority queue. Then I can go through each one of my entries. I can do for const num and num frequency of object entries of frequency. I can say max frequency on queue the num, and I think the second argument is priority, right? Element and priority. Yeah. Num frequency. Let me just explain this real quick for anyone that's new to my streams, because I do this sort of thing a lot. So what this does is it first tries to find frequency of n in frequency. So let's say num here is 1. The first time this comes around, frequency of 1 is undefined. So if you try to do undefined plus 1, that's going to give you not a number. And because not a number is a falsy value, it's just going to go on the right hand side of the expression and set it to 1. The next time we get to another 1, it'll see that 1 does exist, so I'll just do frequency of n, frequency of 1 plus 1, and we'll set the frequency to 2. This is just standard max priority queue from this library up here that we found on the LeetCode environment site. And then over here, what I'm doing is object.entries returns an array of key value pairs, where the key is the key of the object and the value is the value at that key. And here that we're just using array destructuring to be able to say the num and the num frequency, where num is our key and num frequency is our value. And then I just on queue each one of these into the max frequency. So that way we end up with our, I guess, degree. So really, like the degree now, I think we say highest priority. So this is going to return something with priority 1 and elements. So the degree, the input array has a degree of 2 because both elements 1 and 2 appear twice. So if we want the priority, we should say that the const degree equals max degree, max frequency of front dot priority. So let's print this out and see if we get the right thing just with that so far. I'm just looking to see if we have the right degree. We have 2 and 2. Okay. Two and 3. Okay, that's fine. Yep, the degree is 3. Okay, cool. So now what we need to do is we need to find the smallest possible length of a contiguous subarray of nums that has the same degree as nums. So if we're starting at 1, 2, 2, okay, here, it's like if I'm starting in the first one, we only have 1, 1. Here we have 1, 1 and 1, 2. Here we have 1, 1 and 2 2s, and because we have 2 2s, that's the same degree. So I feel like at this point we should say, okay, now that we found the ending of a place where we have the degree, how much further can I decrease this to get the same thing? Now, what happens if I have something like this? Or like, because it could just be on this side. Because like, what if it was, would it matter if it was this? If I find, right? Because here, this would be 2. And here, this would be 2. I guess this could be like 1. Maybe this could be one way of doing it. And then we get to maybe the next window, which would be like here. Now we've lost the degree. So it's like, do we keep going? Okay, we found another degree, so that's fine. Now we lost the degree. So we keep going this way until we're back at this degree, and then we see the end. It could be something like that. But I'm a little bit stuck on like, that's the part of sliding window that tricks me, because how do I keep track of like the current degree? I have 1, 1, and 1, 2. The next time we get to 2, okay, and we get to 2, is the degree just the maximum number of those? Also, I'm curious, like, no, that's not going to make sense. I was thinking of, yeah, maybe there was another way of doing this. Degree of an array. Two is the shortest length. So does this mean that we just need to find the smallest array that has degree of the same number? So when I say degree, I mean the smallest array that has 2 of the same number. Smallest array that has 3 of the same number. So maybe this might be better. Let's go through this example. Let's say we have end here and we have start. Okay, so here we only have 1, 1, and we're looking for what? 3, right? That's the degree 3. We have 1, 1, and that's it. 1, 1, and 1, 2, 1, 1, and 2 2s, 1, 1, 2, 2, 1, 3. Oh, well, actually, that's a terrible example because we'll only ever have, yeah, now we have 3 2s. And that's going to be the answer. So, like, at this point, what? Like, I start like decreasing the window from the left, and I'll say something like, okay, now we have 1 1, but we still have 3 2s, so that's fine. Okay, but then as soon as I go here, I lose the 2, because end is already at the end. When I go forward, that's bad, right? So I guess whenever end reaches the degree, we take the length, and that could be like some length. Now we start increasing. And I guess we should remember the number that gave us that degree. Yeah, there's a lot of things going on here. Because like 2 is the thing that gave us the degree. So then we'll start going here. This is very confusing for me. I almost want to see if like, let me see what another question will be. Is this, and this is not even, I mean, actually more people like this question, so. Oh, diameter of a binary tree. I think I've never figured this one out. I've never figured that question out. That question's like really tough. Degree of an array. I feel like I need to think about this one a little more. I don't want to try and spend the rest of the stream just dwelling on this one, but I mean, we know that this piece is okay here. Figuring out the sliding window part. And let me see if, I'm going to look at the topics. So array and hash table. So apparently we don't even need a sliding window. Array and a hash table. I mean, do we just need to find, or maybe if we already have the frequency, maybe we just keep track of like, yeah, I'm gonna need to think about this one a little more. So I'm gonna go ahead and move forward to diameter of binary tree, and maybe we'll get back to that one during the weekly roundup. Yeah, this one has always stumped me. Because like the longest path between any 2 nodes in a tree, this path may or may not pass the root. I've always thought of this in like one way, and then it's just always wrong. So 4, 2, 1, 3. Because in my like it seems like it could be like just the longest path on the left plus the longest path on the right. But I guess, well, the longest path from here and the longest path here, I guess we can just keep track of that max every single time. Any path between 2 nodes represented by a number of edges between them. it's almost like I want to find, let me think about this. Maybe, I mean, is it just the maximum, like, okay, get the maximum path for the thing on my left and get the maximum path for the thing on my right. So here we'll have 1, 2, and here we'll have 1. And then we also need to include myself. So I picked the longer of the two, or maybe I just add. I had 2 plus 1. See, but now it's x3 is the length of the path 4, 2, 1, 3. Do I just subtract the 2? If I do a 1 and a 2, or do I just subtract 1, 1, 2, 3? If I do 1 and 2 and that has no child, so there'll be 1 and 2 and then null here. It's 1 on my left and none there, but then that would just give me 0. That's the problem. 1, 2, 3. 1, 2, 3, 4. 1, 2. Oh, unless we do like plus 1, because it'll be 2 plus 1. And what, just minus 1? Because then it's like, why even return plus 1, 1? Yeah, I'm not sure if it's that. If it's like the max, like we get the max of the left, max of the right. We add those two, and that's like 1 max. I mean, we can do something like let max diameter equals 0. Here we'll say const max depth of root. If not root, return 0. Const left equals max. I mean, this is just the standard algorithm, right? Root dot left. Const right equals max depth of root dot right. Here we'll return math.max of left and right plus 1. So for here, we do 0, so this is just 1. We go over here, max depth of root. So what's the max depth of, and maybe, well, yeah, we'll start down here. Should we return 0 for this? If not root, return 0. Maybe I should just say if it's a leaf node, return 0. Plus 1, because I want this one to be 1, not this one. If not root or not root dot left and not root dot right, return 1. Else if I'm just given a 1, 2, and an empty one here, maybe I can say the depth of the left here is 1. And the depth of the right, that's just 0. See, but then plus 1, that's going to give me 2. I don't want the 2. Unless we just do minus 1. Max diameter minus 1, that seems kind of strange. Let's see. So here we can do, actually, and I think this one needs to go, I should put this outside. And then we also just like remove all this stuff. Let max diameter equals 0. And maybe also here we should put this outside. Let me just make this all consistent. Okay, so here, let's see. I can say if not root, we can return 0. And then maybe what I can do is just go diameter here, root dot left, diameter of binary tree, root dot right, Okay, and then whenever we're here, we can get, let's see, const left max equals max depth of root dot left. Const right max equals max depth of root dot right. And then we'll say max diameter equals math.max of left max or right max minus 1. Return max diameter. Zero and 3. Okay, wait. Oh, wait. Math.max of max diameter or left max plus right max minus 1. Now this, I feel like I might be off here. So I almost just want to do this. Although that's going to be the same as me doing it anywhere, but let's see. Still 0 and 3. Max diameter is 0. Math.max of max diameter or left max plus right max. Diameter of binary tree root dot left, root dot left. Root dot left is 0, root dot right. We come over here. If not root or not root dot left and not root dot right, return 0. Okay, then we get here max depth of root dot left and root dot right. Return math.max of left and right plus 1. Why would this stay at max depth root dot left? If I come over here, I'll get root dot left and then root dot right. I'll get both of these. That's 0. So it's 0 or 0 plus 0. And then here we actually, I guess we return negative 1. I don't even know why that's 0, but unless I should be returning return max diameter. Something very strange happening here. Like when I get to the 1, I'll eventually come up to the 1. I'll do the left and the right. Okay, so I come up to here. If not root or not root dot left and not root dot right, that's fine. So const left equals max dot depth of root dot left and root dot right. Okay, so both of these are 0, but then we add 1 here because we have an edge between each one of them. We just got done doing the left of this one, so we return wait, so left and right, that's 1. We just got done with the left here and we got 1. We come over here and right. Okay, so this is 2. If I start at 1, that's 2. And then minus 1. I wonder if I just did max diameter, like what would this give me? Am I still going to be left with 0? 1 and 3. Wow. So like really off here. Unless it doesn't like that I'm doing this one, but at this point I'm just sort of guessing. Yeah, the thing is, like, I've gotten here before and I feel like I'm not doing, I feel like this is not the right answer. I mean, maybe it could be, but oh, I guess never say never, even though I don't think I said never. But well, there you go. There you go. Wait, how is 1 and 2 3? That's crazy. Output is 3? Right. Okay, well, we're approaching the end, and not to like make excuses or anything, and this is not even related to LeetCode, but I haven't eaten lunch today for whatever reason. I got like really caught up at work, so I'm very hungry and it's hard for me to think right now with a growling stomach. But either way, I'm very happy with the questions that we solved today. I mean, we did a ton. We normally don't even do this many on a stream. 277, so we did 2. Yeah, we did 4 of them, which is nice. Normally we average like 2 to 3. I think anything more than 3 is very nice, so I'm very happy about this. So thank you all so much to everyone that watched today. John Taylor, thanks for sticking around. Appreciate you being pretty consistent with your attendance. That's awesome. Always nice to see other people being consistent with their attendance. And yeah, with that being said, if you like what you saw, make sure to subscribe to me on YouTube or follow me on Twitch. If you want to get sort of like a overlook or an overview of everything that I've essentially done since I've started the channel, rafaelslist.com essentially is like a compendium of sorts. It's like the Bible of the channel, and it gives you resources to everything that I've done. So this is a good place, a nice hub for you, if you will, of all the content that's pretty much available on both Twitch and YouTube. So with that being said, hope you all have a great rest of your Wednesday. We're one day close to Friday, past hump day, which is awesome. So yeah, hope you all have a great rest of your Wednesday.